Hello, hello, good afternoon. I am dialing in from the office today. So I'm working from down here in Cupertino. Welcome to episode number 131, in which we play a little bit with tetragon. We play a little bit with that XZ, the existential crisis. That was that crazy SSH thing. That was pretty amazing. So today we're going to be kind of playing with that a bit and kind of showing you how to reproduce it, how to detect it, and potentially stop it with tetragon. So pretty neat stuff. Kind of a really good way of actually showing some of the amazing data that we get with tetragon. If you're out there listening, go ahead and say hello in the chat. It's always nice to see that folks are tuned in and interested in what's happening. Let's go ahead and get started with the events. So we just kicked off a new series. It's called Buzzing Through Kubernetes, Unleashing the Power of Cilium for Network Engineers. It is a two-part workshop. We just did the first part yesterday. Hey, hello. Welcome, good to see you. Just did the first part of it yesterday, and the second part of it is coming up on the 23rd of April. So definitely tune in for that. That should be a lot of fun. Next week, you can find me and a bunch of my cohorts in Seattle for Open Source Summit NA. So if you're up there, definitely come by, say hello. I'll be there the whole time, one way or the other. We've also got KCD New York coming up at the end of May. I'm going to try to make it to that. I'm not totally sure that's going to happen for me, but like it's possible. However, in June, coming up in June, we have the 26th and 27th, again in Seattle, which is going to be another one of my favorite conferences. This is a spin out. It's called Cloud Native Security Con, and it is basically a spin out conference for the CNCF that really focuses primarily on cloud native security. If that's your thing, if that's what you're interested in, which you probably are, if you tuned into this episode, then definitely consider going to that conference. It's a lot of fun. Those are the events. Let's jump into the news. Remember that, as always, if you want to subscribe to this news, what you can do is you can just go to cilium.io/newsletter. And here you can see all of the previous newsletters, and you can also subscribe. So you could just subscribe by dropping your email here, and you will get this news every week, or you could just keep tuning into Echo Office Hours and kind of go through it with us. Hello, Stelb2. Good to see you. I'm glad you're here. So the news this week is actually a big week for us because, you're going to find out later this afternoon, but it's a really big week and I'm super excited. Lots of really great stuff happening. One of the things that we put out this week was a great blog post by my friend Jalal, who actually helped me, who was somebody I worked with to actually understand this exploit and how it all works. So he's a really great resource here at Isovalent, and then also one of our awesome content creators, Mr. Jeremy Colvin, worked with him to create this blog post. Gets into really good detail. If what you want to understand is more about like the actual exploit and like what the surrounding events and those sorts of things are, then I definitely recommend this blog post because it really gets into a lot more detail around that bit of it. What I'm going to do here in this Echo Office Hours is really focus on like how do we detect it and kind of show you how to create a simple reproduction environment where we could prove that we can actually detect it and that kind of stuff. Yeah, there's even a really good cheat sheet, XC Outbreak cheat sheet that really kind of digs into it by Thomas Rokia, but really great stuff. This is one of the examples of what we're going to do here, and I feel like this example is super awesome. We're going to come back to it, but this example really kind of describes some of the neat capabilities. Since we're operating with Tetragon, we're kind of operating in the Linux kernel, and we can hook in anywhere we want, right? So in this particular example, what we're seeing is we're going to create a K-probe, and we're going to watch for the security mmap file. Now, if you have done like a strace of an application, like one of the things that you see is like the inrush of libraries that are being pulled in when an application starts up. And the security mmap file is kind of a part of that. It gives you the ability to understand what its dependencies are, right? So Another way to see the part of the mmap file that we care about in this particular scenario is to actually do something like LDD, right? With LDD, you'd be able to see the libraries that are also a part that are being loaded by this particular binary when it's in use. This tracing policy, what it does is it basically does a watch for anytime the binary user bin SSHD happens, is in use. And if you remember that because this is a daemon and it's SSHD, it actually activates whenever somebody SSHs in or uses that binary. That's when you would actually see this activity. So it's not just on startup, right? We're not worried about just catching it when the SSHD binary starts, or when the service starts. We will also be able to detect it whenever it is used, and we're going to show that in this episode. When SSHD is used, we're also going to watch for the following values. Now, this is based on the heuristic that we know about this attack today, which is that these particular versions of this library, the liblzma library, are compromised. And if you use SSH and these libraries together, then you have effectively a compromised host. And so if we can alert that this is happening, then we can at least help you understand what hosts are compromised. If we can block it, then we could basically, it's a tricky one with a block, because if you think about it, like if I were to have the response that I would block traffic whenever SSHD is using these libraries, then I'm kind of blocking SSH, which could be bad. Like if you don't have some other way into the machine, that can be rough. So in this particular scenario, notification is probably better. Because with the notification, you could actually just push that notification into your Splunk or some other SIM environment, and then you'd be able to just go through and say, okay, now which machines in my massive, huge machine farm are the ones that are compromised, and how can I go about remediating them and ensuring that they are not compromised. All right, we're going to dig into it here. This is a great example of the event. I'm going to show you that as well, but we're going to get into it. First thing we need, though, is we need a way to reproduce this, right? So let's go ahead and start there. I found this great article on kali.org, which is just one of the many security sites that are out there. And in this great article, they really describe very, very simply how to reproduce this particular scenario, and even a reasonable way for validating that the reproduction works. So my intent here is to actually create a compromised kubelet, because I want to just use like the regular tetragon to do this. So I'm going to go ahead and wipe out the clusters. I'm going to scroll this up a little bit. Ooh, that's way too much. There we go. Clear, Docker PS. All right. Oh, trippy. Okay, well, Docker rm -f. And control. Docker kill minus. Having a weird problem where a container I have running won't actually die. Okay, let's see if that helps. Oh boy. Well, okay, Docker, kill. Well, we're going to move on here. Let's see if we can do kind, create, cluster, config, kind, CNI, name, echo. So I'll figure out why that container's not dying in some future version of this, but let's not get hung up on that for the moment. My intent here is to create a kind cluster because it gives me an easy way to create a machine that isn't only accessible from within my local network, and that I can actually make a compromised machine. So let's try this. Let's do Docker exec ti echo control plane bash, and then we will do apt update, apt install open SSH server. Because kind nodes don't come with an SSH server by default. And if I do LDD cat SSH or which SSHD, we can see this liblzma so.5. So what I'm doing is I'm just installing SSH. I can see that this library is being pulled in. I don't know if this one is the one that's compromised because I've only just installed it. So, and I also just did an apt update. So it's unlikely this is the compromised one, but let's go ahead and see by using this script that they have been so kind to provide us. Let's try that again. Cat detect SH. Okay, so what this script does is it tries to determine is the path to liblzma even in the system? If it is, then let's check for a particular function signature to see if things are vulnerable. Oh, I don't have hexdump. I also don't remember what the command is to install hexdump. It's like bin something utils. BSD main utils. There we go. Let's pull that in. Okay, so now let's take a look at this command. Let's see. Let's do change mode plus X detect, probably not vulnerable, right? So that means that while I do have SSH running, I am probably not vulnerable to the attack because the version of liblzma that I have is different than the version that is vulnerable. So let's do time SSH localhost. We can see the real time here is 15 seconds or 15 milliseconds, microseconds maybe, super tiny. And that was one of the mechanisms that they used to detect the vulnerable versions. I mean, that was if you've been following the news here, it's been pretty fascinating how people got caught, how people caught this. So to see tetragon used to backdoor. And so, like if I were to go ahead and install tetragon in this scenario, I would see that it's not currently running. I would currently see that this guy is it's not going to work because the version of LDT the version of LDD is actually linked against liblzma so.5, which is different than the compromised version. All right. Let's go ahead and make this let's go ahead and finish doing the install on this cluster. So we'll do Cilium install. kubectl pods-w. All right, Cilium is up and running on the cluster. We'll also do helm install tetragon. And to do the helm install for tetragon, we're just going to point to the Cilium tetragon helm repo that I have installed, which is just a Cilium helm repo. And I'm going to drop it into the kube system namespace. All right, tetragon operator is up and tetragon is up. So now we have tetragon running. Let's take a look at that tetragon tooling here again. And the tetragon tooling here is a tracing policy that does exactly what we were talking about before in our example in the blog post, right? You can see it's looking for the user bin SSHD binary. It's going to match on arg0 in the post part of the actual memory map, and it's going to look for 5.66, 5.60, and 5.61. Right now we don't have that. We have 5. So let's try to apply this. kubectl apply -f xe detect, and if we do kubectl exec tf -in system ds tetragon -c. Tetragon, what this is going to do is it's going to exec me into the tetragon container in the daemon set tetragon. And I only have one node, so it'll just connect to the only one that's there. And we'll do tetra get events. Actually, we'll do tetra status. just jump in with bash. Tetra is the command line tool that allows us to kind of interact with tetragon. It's interesting. We see tetragon running. Okay. So we see everything seems to be working, but for some reason we're not. Actually, we don't have anything turned on at the moment, so that other than the one tracing policy, get tracing policies. So that should be enough to get us there. I'm thinking it's possible that I'm actually conflicting with myself here somehow. Okay. Keep Kernel. Get paused actually. See, it's up and running. All right, well, let's see what we get here. Something weird is happening. Let's try this one more time. Weird. Okay, so I'm running into some kind of weird behavior here. So I'm going to just jump onto a different host and we'll try it over there. No, it's not running. Uh-huh. The demo gods are really coming for me today. So let's see if we can beat them out despite their significant attempts to stop my current progress. Debian-based distributions were never pulled in the vulnerable version. Yeah, exactly, because they were in the stable branches. That's correct, Marcos. Which is why the version that we see in our in the demonstration that we're doing here is actually before the version, because it's still on a stable branch. But I would still like to show you this. So let's see if we can get far enough to actually do that. Okay, so we only have the echo control plane now. That's better. Wow. Then get it done. What are you waiting for? Man, just went through this like a couple days ago. Everything was fine. And today, not so much. Create cluster. Config. Oh, you know what it might be? Yeah, so this is probably not going to work. But let's see if we can get something to work. Anything really. Oh, all right. This is very frustrating. Let's see. How can I solve this problem? I feel like I'm kind of in a corner here. Let's do this. Gcloud compute instances. The struggle. It's terminated, so let's just start it. Start. And we'll jump into that box and see if we can get things going the way I would like to see going. Let's see. Okay. SSH. Sorry, what? What kind of game are we playing? Cloud. All right, fine. Whatever. Docker PS. Okay. Kind. SCP. Okay, here we go. Okay, so now we have Docker. Let's move. Let's see. We get rid of these patches, which basically pull in a cache on my local machine. Kind, create cluster, big, kind, no CNI. Haha. Grab kind. We'll go to releases. We'll grab the latest for Linux AMD. We'll pull it down. We're pulling it back here, folks. We're trying to get this to work. Just bear with me for just a minute. I'm almost to a place where it's going to work, I think. I'm not sure what. I think what happened was I had upgraded my Linux kernel recently, and when I did that, I may have actually busted the compatibility with Docker. So that happens. Okay. Find clusters up. Let's do Docker exec ti control plane bash apt update apt install SSH server. Let's do our time again. So we'll do time SSH localhost, about 9 milliseconds or microseconds, I guess. And then if we also take a look at that LED command that we did before, which SSHD You can see we have LZMA SO5. So everything is looking pretty good. Let's grab that script again. Copy, paste, bash, apt install HTML. So detect here should tell me that I'm not detectable, plus X, detect.sh. No, probably not vulnerable. Okay. Next up, let's keep going here and see if we can get this all lined up here. So we'll do Cilium install. Helm repo update. Helm repo Helm. Cilium. Yeah. Okay. Stop that. All right. Helm install tetragon system. Cilium tetragon. Kernel. /A. CP. Cilium's running, tetragon's running. Kernel log/in system ds tetragon tetragon. That looks much better to me. Let's pull our map over. CP XZ. And let's apply it. Let's check to see if we see what we expect to see. Hey, there it is. Excellent. All right. Okay. So now if I go to the other one. Oh, now so things are working. We're starting to see events. We're seeing an exec event for the local path startup and that kind of stuff. So now we go back to tetragon. Dash. We jump in. Sorry, what? Oh, I see. Exec dash TI. Tetragon. Here we are. Tetra status. Much better. Tetra So I want to see get events. We can do short, I think. No. There is an output -o output can be compact. And the compact output is actually really cool because it gives you kind of a view into what's happening, but doesn't make it too outlandish. So let's jump in. See, now we can actually see stuff happening on our local file system. Pretty cool. Things are working. So Tetra is working. I'm able to see stuff. I'm able to see things happening on the underlying host. I can see processes kicking around and doing their fun stuff, and that's all great. Okay. Next up, let's make this box vulnerable. And the way that we're going to do that is we're going to do docker execti control plane bash. We're going to do time SSH again, localhost. System CTL status SSH started. So let's go ahead and go back to our reproducer here. Now what it's going to have me do next is grab a snapshot of a bugged version, of a compromised version of the XC library. So let's go ahead and do that, because that's how we roll. Copy, curl minus, paste that in there. And then we will just install it. Install downgrades, although this is an upgrade. Yes. CMA. Okay, now we should see it's upgraded, right? So we upgraded lib LZMA 5. We upgraded to 5.6. So now if I do system restart bash, SSH, and I do SSH time SSH localhost. Let's get rid of the root passwords. We can see that's significantly different. That's 0.6 and not 0.009. Way different. All right. What if we run the detect script again? Probably vulnerable. So now we should be able to actually see that there are events that are being triggered, and we should now be able to actually see that this is actually functioning. Before I do that, get nodes -oy. This is my IP. It's running my compromised SSH server. Keygen. What I'm doing is I've just made a key, and I'm going to copy the public key into the authorized keys. So RSA pub. Authorized keys. Now when I do that, it should work, which it does. Okay, so now I'm going to pull this down, make this full screen. And let's check on you guys, because I just realized I haven't actually been watching for comments, and you've probably been commenting. So let me come back. Oh, you haven't said anything. All right. Well, let's keep going. So here's what we got so far. We now have a compromised SSH server running on a kind node. We have tetragon installed. We have the policy installed. Let's go ahead and jump into the tetragon container again. -ti. So here we are on the tetragon container. We do tetra get events. So tetra get events is working. I'm going to do -o compact. Do processes. And this is an interesting one, because if I do get events, I see all the events that are able to be picked up by tetragon in its current configuration. But specifically, I want to see processes that are related to that SSH binary, right? So that I can actually see if the trace I'm doing is actually producing interesting output. So in my case, I'm going to do tetra get events, and I'm going to look for the SSHD process. And in theory, like, I shouldn't really see too much happening in a steady state, because there's nothing triggering it. But oh, that's confusing, because that's the SSHD of the underlying vagrant host, not the actual SSH that we were expecting to see here. In fact, let's see if we can make that less confusing. So I'm going to SSH in to and it is interesting that, because when I did SSH in, you didn't see any output, because the machine I SSH into is not compromised. It's the SSH server running inside of that kind control node that is compromised. So when I do this, I am expecting an event. And there it is. We have shown it. How cool is that? So this is the compact version of the information. Okay. And that tells me that when somebody SSHs into this host is actually compromised. But if I were to, again, to kind of jump back out and SSH into the host itself, Tetragon operates at the kernel layer, which means that it sees the event, regardless of whether the event is happening on the host layer or inside of a container running on that host. It sees the event in both cases, which is pretty neat. But let's do this. Let's do I have JQ? No. Apt install JQ. Sorry, what? Oh, I see. Docker exec. No, that's not going to work. DK add JQ. Hot. Okay. Did that work? It did. I want to get rid of compact. And let's see. I'm going to pipe this to JQ dot. And now if I SSH in, so this is my SSH to the host. The node name is still kind control plane because kind control plane is the container that's running. It's actually really hard for it to understand that this is running on the underlying host and not within the container because of the nature, because the container and the host are sharing the same Linux kernel. And I'm instrumenting the kernel from within the host container. So that's an interesting one. That's a really interesting thing. So that's all of the information we get when we see this event. Now let's do it with our trace component. Right? And here we see the security memo mmap file we were matching on liblzma561. It says, hey, I found it. I have created an event for you indicating that this binary, when it was accessed, did make use of this policy and did actually produce results. So that, my friends, is how you do that. That is a pretty simple reproduction in a pretty simple way of validating how this works. Now, there's actually one other thing I wanted to show you before I go off and do other fun, crazy things. And that is not only is there a blog post on how to actually reproduce this stuff, but this is a growing library of examples. So here I am on Cilium, tetragon. Inside of the Cilium tetragon piece, there's this thing called policy library, which actually includes a bunch of different examples of things, including CVEs, and this one here, the XE/SSH CVE. And I know that Dalal is working on a couple others as well, and so this library will probably continue to grow. So as as these CVEs come out, they're going to give us, we're going to work on making those things kind of accessible from within a policy library here. If you see something that you think Tetragon will be a good match for and you want to contribute that code, you're very welcome to do so. There's lots of really great stuff, lots of really great, interesting use cases for Tetragon out there. In the meantime, thank you so much for tuning in. I hope this was educational. I found it, a challenge, of course, that the demo gods were coming for me so hard, but at the same time, I really very much enjoyed sharing what I was sharing with you, and I hope you have a wonderful week. And I will see you all in a couple weeks, unless you're in OSSNA next week, and then I'll see you in Seattle. So thanks for tuning in. Thank you, Richard. And we'll see you all next time.